Welcome everybody to our WeYield Academy London 2019 edition. So I will present you how to anticipate the future with a demand forecast inside the WeYield piloting tools. So like Emmanuel said, I'm Christian Cadéré and I'm the CTO at WeYield. And I oversee the development of this new and very exciting feature. So the basic question we ask and that everybody asks is how can we predict the future? The fundamental principle of a scientific approach for a prediction is determinism. It means that the future can be determined by observation of the past and of the present. That means we want to look at the past and the present and search for laws that can determine the future and make a scientific prediction. If we try to make a prediction without observation of past events or present events, that's fortune telling, divination, you call it as you want, but that's not scientific at all. How do we define the forecast precisely? So forecast is a type of prediction, of course. So it's a process of making a prediction of future based still on past and present observation or data, and most commonly by the analysis of trends. So that's the key word when we talk about the forecast. It's trend analysis. So it's same as prediction. We look at past, present, but focus and put the emphasis on trends. You all know a very used forecast. Maybe every day you look at the weather forecast. So how does the weather forecast work? It's a very scientific approach. They have models about air currents, air temperature, and they have analyzed years and years of past data. But the key point for an accurate weather forecast is the trend, is what is the actual situation, what is the actual trend of temperature, moisture, winds, and so on, to be able to connect it with the observation of the past and make a forecast for the next 3, 5, or 10 coming days. So it's really the mix of past observation and trend analysis, present trend analysis. That's what allows to make an accurate forecast. So that's just a generic introduction of the concepts of prediction and forecast. Just a quick reminder, we go back to the WeYield apps. For the moment, in the apps, we show an estimate. So for those who are users of the application, we give you inside the application an estimate of the future demand. So how does it work? If we look at the 1st of December 2019, we can see that at the moment we have 177 booked reservations, and we show an estimate of 692. How do we compute this figure? We start from how much we have booked right now, and we look at the same date last year when we were on the Wednesday 7th of November 2018. We had 420 reservations booked for the 1st of December, actually the Sunday 2nd of December 2019, because we always compare not the same date, but the same day of the week at the same date, so the same Sunday at the beginning of December. So we had 420 already booked at the same day last year, and we finished at 935. So to compute the estimate, we make the difference of the actual pickup that happened last year between the 7th of November and the 2nd of December, so 935 minus 420, meaning that we booked 515 reservations during this period. We add it to the current on rent on today, 2019, and we end up with an estimation of 692 reservations for the 1st of December 2019. Is it clear? So the estimate is a pure prediction. It's based on the present state, how much I have booked right now, and the growth of the same period last year. So we look at the present, where I am at today, and how much I picked up last year during the same period. So why did we include the estimate in the apps? It's in order to provide an indicator, even if it's approximate. We know that's not perfect, but this indicator allows you to determine commercial actions. You can, knowing that you will have a low or high, who knows, amount of reservation, then you can decide to adjust prices, adjust stocks, push a distribution channel, put a stop sell, I don't know, you know better than me what you do according to the future demand. But this estimate allows you to have an idea of what will happen in the future. And for those of you who have quite regular business over the years, actually the estimate is quite accurate. So it's really something on which you can take actions, meaningful actions. But we know that it can be imprecise. Often it's imprecise. Too much weight is given on only the last year. So what happened last year will determine the estimate for this year, only last year. It will not take into account the actual trend. If there has been a big increase in your fleet size or things like that, it cannot know because it will only look at last year's increase of pickups. So, like I said, it can work well for seasonal and regular activity, but it cannot take into account exceptional events like strikes, like what happened in France with the Gilets jaunes. It cannot know. It cannot. It will take for the year it happens. It will not take it into account, of course, and the year after it will blindly repeat the patterns that happened because of the Gilets jaunes, even if next year there are no Gilets jaunes crisis. If there is a sports event, it's the same thing. It happens only 1 year. With the estimate, it will impact the next year, but it has no sense because the event has finished. And it can be the same with bad weather that can influence some touristic destinations. So that's why we asked the question, how can WeYield help you to better anticipate your future demand with a forecast? So what is a forecast? First, it's an AI tool, and it's based on machine learning algorithms. So these are very nice words, buzzwords at the moment. Just a little focus. What is artificial intelligence? It is just the simulation of human intelligence processes by machines. It's simulation. It's not something magical. It's not the machines thinking by themselves. It's simulation of human intelligence processes. These processes include the ability to learn, to reason, to take actions based on what the machine has learned, and self-correction, learn from mistakes or success, trial and errors. So that's artificial intelligence. And what is machine learning? Machine learning is a specific field of research and techniques to implement artificial intelligence by letting the computers learn by themselves from examples that are given as input. So we feed examples to the machine, and the algorithms will learn by themselves, analyzing the examples and finding correlations between the example and a target. So this is totally different from the traditional approach of programming, where a developer will write instructions, if this, do that, if that, do this, while this is true, do this. So the traditional approach is limited by what the developers can implement and tell the machine to do. Machine learning is, this is the example of a data set, this is what we wanted to achieve, find by yourself the correlation between the example and the target. And the machine analyzes and finds by themselves, and the programmer doesn't know necessarily what the correlation are. So it can be like a black box. The computer has found correlations. It gives an accurate answer, but we don't know in detail what the machine has found. Yes?
So let's say there's an upcoming event in the future that has not been there in the previous year. It's a new event for that year, end of the year, let's say, and you're in quarter one. How will the AI calculate the estimated pickup Based on what information would it be?
If you have trained the machine with past events, and so it has learned to find correlations between these events and on-rent data, actual bookings. If when you will ask to make a forecast, if you tell the machine in X days or weeks or months there will be this kind of event, if it's the same kind of event as in the past, it can adapt and include this event into the forecast. We will come to that. So for the moment, we have implemented a forecast in order to have a better understanding of on-rent data and try to find correlation between past on-rent values and given time parameters. So what year it was, what month, what day of the week, was it a weekend or not, because it has a great influence of bookings. Was it a holiday? What date of the year it was, because there are some fixed dates with celebration or local events. So all these kind of time parameters in order to find the correlation between what were the bookings in the past and these parameters. Another key point of the forecast is that it uses all the available historical data. So contrary to the estimate that just looked at last year's pickups, the forecast is able to analyze all the data going in the past for your activity and find the correlations 4 years ago, 3 years ago, 2 years ago. The more data you have, the more correlations you can find. We have implemented several machine learning models, 4 to be precise, because there are thousands actually of machine learning models, and each of them have biases, are more prone to be conservative towards the past, or more prone to include the trend, to give a big weight on the trend of the past days. So nothing is perfect. You cannot find the perfect machine learning algorithm for everybody, neither the perfect machine learning algorithm for one client. So what we did is we took 4 major machine learning algorithms that are recognized as such by the field of research, and we implemented all of them in order to make a competition of machine learning algorithms and try to make the most accurate forecast. So we want to use as much data as possible in order to be adaptive to every client's dataset's specificities. You don't all have the same seasonality, the same amount of cars, the same pattern. So it's very important to be adaptive and try to adapt to your specificities. I will just make a small focus because we use the term data everywhere. Everybody talks about data, it's data science, we learn about data. So just a small focus of actually what is data and what is your data, the data that we use for the forecast. So data is a set of value that we observe over time. Actually, it is chronological time series. So we have on the x-axis we have time, and on the y-axis we have a value that we observe. Here I have an example from the amount of airline passengers in the United States from 1949 to 1960. So what the data is what we observe. So we observe a growing number of airline passengers over time in the 50s in the United States. And in order to understand the data and be able to make a forecast according to this data, we have to split this data into 3 components. The first component is a trend. So it's basically the average growing number over time. Very important one is the seasonality. It's a pattern that repeats every month, every year, and really allows to understand over this trend how much the data will vary over months. And once we have decomposed the data into trend and seasonality, we have some leftovers, let's say. There is data remaining that we call noise or residual data. That's the unpredictable part of the data. Sports events, strikes, weather, new airline opening, things like that, that happens randomly or happen once every time, and that cannot be split into a pattern, a seasonal pattern. And this is actually a multiplicative decomposition. That means that if you multiply this value with this value with this value, we obtain this value. So that was a general concept of what is data and how do we split and analyze the data in order to be able to make a forecast. Are there questions on this part? Okay. So back to WeYield. How does the forecast work precisely in the application? There are 4 main steps that we do every day in order to forecast the on-rent on the 30 next days. So it's like the weather forecast. The weather forecast is over the 10 next days or the 15 next day. It's a bit the same for WeYield. We choose a time window of 30 days in order to maintain accuracy. The more in the future we try to forecast, the less accuracy we can get. So we decided to forecast a 30 days period. So first, like I said, we gather all the past data for a client. So it contains its own trend, seasonality, and noise. And then we add for all these dates on the x-axis. So we have the on-rent data on the y-axis, and we can have the fleet data, but I will talk about it later. What really interests us is the on-rent data amount, so amount for each day, and on the x-axis the days. So we gather this data, we feed into the algorithm or for each date, like I said, year, month, weekend, holidays, and things like that, everything like that. And then we split the data into 2 data sets, the training data set and the validation data set. So this is the part where we choose the best model. So how do we make this model compete? We ask this model to make a forecast of the last month, the last 30 days. The last 30 days will be our validation data set. And with the rest of the data, the training data set, we give this training data set to each of the 4 models and ask them predict the last 30 days. And then we are able to compare each forecast, each prediction, and choose the model that made the most accurate prediction of the last 30 days. When we have chosen this model, we train again the chosen model with all the data, so including also the last month, in order to give him the trend of the last month. And then this model will make a forecast of the next 30 days. And this process is repeated every day. Every day, we put into competition the 4 models. We split the data, training, validation, take the better into account, and make a forecast of the next 30 days. So this allows us to show in the apps forecasted on-rent values for until 30 days. And in the past, we are able to show you what was forecasted 7 days, 1 week before, 2 weeks, 3 weeks, and 4 weeks before. And we are able to compute how accurate we were for this specific forecast. Because it's very interesting to make a forecast and say, tell you a figure for the future. But if we want trust and if we want you to use this value, we have to show that actually this is an accurate prediction. In the past, it was accurate, so it should be accurate in the future. So let's go to some examples. So here I have a forecast of the month of September. The forecast has successfully captured seasonality, trend. Don't be fooled by the scale. Actually, these values are very close. So in red, we have the forecast for 28 days ago, and in yellow for 7 days ago. So the 7-day forecast is usually better and more accurate. And the mean accuracy on this example is 97% 7 days ago and 95% 28 days ago. So we were able 1 month before to make a forecast of the future on-rent data with a mean accuracy of 95%. And of course, there will always be a margin of error. It's a statistical measure. There will be a margin of error.
Did you test that on which data, on one country or many countries?
Many. This is a specific set, but we have ongoing experiments on lots of different countries and different types of data and seasonality. Actually, it might come from your data, I think. So still we have the effect of noise. Like any prediction, forecast is prone to errors due to noise. Like I told you, for the estimate, noise can come from special events, weather changes, or fleet size changes, shifting religious feasts, errors, even errors in the data. So sometimes we have values that are quite far from reality. But once again, this is, we cannot avoid that. We try to avoid it as much as we can, but not 100%. So let's compare a bit the forecast versus the estimate. So here, the black line is the actual on rent from past data. The blue line is the estimate from 28 days ago, what was estimated 28 days ago. And the yellow one is the forecasted values from 28 days ago. So we can see that there are spikes with estimate, because estimate, like we said, just makes computation from past values, make a sum, a subtraction. So if there was a big increase last year, you will have a spike. If there was a small increase, you will have a low value. The forecast is much more smooth, because the machine learning crosses many data and parameters, so usually it's really smoother. And on this particular data set, we reach 96.4 average accuracy with the forecast, but mind that the estimate was still 94.5% accurate. So for this client, which was not you, which was not Sweden, as the business is quite regular over the year, even the estimate from 28 days ago gives a good prediction of the future. The forecast is better, at least, but even estimate is a good prediction. I have two small study cases from a Caribbean island. So this is not an estimate graph. This is actually booking pace from the users of the apps. So this is the booking history and the booking pace for this client. And we look at the last week of July. So interestingly enough, during the last week of July, the on-rent value from this year and last year were the same. But at the beginning of July, when we look here, we were very late on pickups. Very late. We were quite late on pickups comparing to last year on rent at that time. So what does that mean? When we will compute the estimate, you can see all where I'm heading at. With the estimate, we will finish around here. So below the real values. So the estimate will be quite imprecise, but with the forecast, we were able to match the actual value and trend of 2019. Another example, it's quite the same. So we are this time in a Mediterranean island, still focusing on the end of July 2019. And we see that we finished this year largely ahead of what we had last year. And actually, we stopped to take bookings at the middle of July. So there probably was a stop sell, and we didn't accept any more bookings. And at the beginning of July, we were already ahead of what we had last year, but we finished much higher than last year. So when we will make the estimate, we will add this value to this value, but still we will be below. Like the estimates show, we still compare the 28 days estimate, the forecast in yellow, the 28 days estimate in blue, and the actual value in black. And here, it's an opposite example. The forecast, the estimate is below because, like I told you, when we add the last year pickups, we cannot reach what we reached this year. And this time the estimate has been more conservative and didn't predict the right value. But it catches up a bit later here because the trend, what did happen here? Why were we not able to predict this value? It's because there was a very quick increase here. We can see that the increase was really quick between the beginning of July and the middle of July. And actually, the forecast algorithm was tuned to be quite conservative, and it didn't pick up the trend in time to forecast this very high value. So, on one example, I'm showing you the upsides of the forecast. To be fair, there are also downsides, and that's still this mix about being very conservative, be conservative and weigh past data, or be more innovative and put a weight on recent data. And we have to find this mix, and this takes time and research. That's why it's still an ongoing process to fine-tune the algorithms to make to have the proper balance between trend and past data. And this is almost like a Formula One. You know, Formula One has hundreds of parameters, and on each circuit, for each pilot, the engineers have to find the right amount, the balance between all these parameters. And we think that it will be the same actually for you, for our clients. Each client data set is so particular that we'll have to find the proper tuning to give the optimal results. So for the moment, like I said, we have 4 general machine learning algorithms that are competing. But this example shows that if we want to go a step further, we'll have to fine-tune and find the right balance of parameters for each data set. But just to finish, so this was the forecast versus estimate value on the month of July. So here the forecast was worse than the estimate, but here it was better, and on the mean accuracy for the two of them is 92%. So even if sometimes the forecast has been more conservative, on the whole, it has been as effective as the estimate and quite effective, 92%. So in conclusion, some precisions. So what do we compute? We compute at the global level for a client. So what you saw was the on-run data for a whole company. Why? Because we need lots of data to have statistical accuracy. We are studying how to segment into groups or regions or brands for clients who will have enough data to be able to make this segmentation, but it's still in study. It's not yet possible. I told you before, we have chosen a forecast of 30 days to have the best accuracy as possible. And like the weather forecast, it cannot be accurate every time. So what are the improvement perspectives? First one, and it's actually an ongoing study, it's SWOT parameters from airline transports. For those of you who have been in Berlin 2 years ago, no, last March, maybe you have met Forward Keys with a company that aggregates data from all brokers and GDS systems from airline company in the world, excluding low cost, but that means 90% of the actual bookings for the future. So they know in advance what is booked at airline company level, and they also have all the fleet plans for all companies in the world that they have to give to IATA months and years in advance. So they really know if the companies put this flight from this point, this destination from this destination, it means that they know that there will be people in the planes. We can trust the airline companies to have the right models to predict actually who will travel from what point to what point. So we think it should be interesting mainly for airport stations, of course, for touristic destinations. And as we speak, the forward key, so who has this data, is running correlations to find if there are correlations between airline passengers flow and on rent for 3 destinations, 3 clients who accepted to share their data: Morocco, Marrakech Airport, Nantes Atlantic, and La Réunion Island. And Forward Keys is making this correlation research, trying to find the right segmentation, because of course it's not the general flow of passengers that can give an insight for car rentals. We have to find the right segmentation of people who will actually rent a car when they arrive at a destination, and see if there is a correlation between those arrivals and pickups in the stations. So if we find this, we will be able to feed it as a parameter of the forecast to increase the accuracy. So like I said, we want to work on data segmentation, because working on a general company level gives you some insight, but some of you really need to have a forecast for a specific destination or specific car group. We want to improve also computation time, because all these computations, analysis, correlation research, and parameter tuning takes time, so it influences accuracy. One of the things I'm researching is trying to mix the two worlds, our two estimators, the estimate data, and try to feed it into the forecast. Why not? Why not use the estimate who gives already an accurate prediction of the future, and try to mix it with the forecast? So I have some interesting results, but anytime we begin to input into the forecast actual client, what happened, a client behavior, it's risky, because maybe there was a stop sale that year, or maybe there were very low prices, there was a very aggressive strategy during the time period, so there was a lot of pickups because of an aggressive price strategy that is not repeated in the future. So maybe using only the estimate, we will put a flow inside the forecast. And that is the same with fleet data. In Paris, we hadn't begun yet to look at the fleet history and fleet plan, and everybody told, but why don't you input the fleet inside the forecast? I tried it, because it's very interesting, and it's the same. It can give very good results and also very bad results. Why? Because some of you might pilot your activity and your business with the utilization, with the fleet plan, trying to maximize and adapt and have a target of 80-85% utilization. Others won't do this or won't do this every time, and this will input noise into the forecast. Because if in the past you made some commercial decisions according to your fleet, but you don't repeat them, or you don't repeat the same decisions, then the forecast will be flawed. So it can benefit or put a risk and make the forecast worse. So speaking about price strategy, that's something that we are also looking at, because it's another module that we are developing. We are trying, and I think Emmanuel will talk about it, and Noemi. We are trying to put in the apps a pricing pace module that will show you for a given day the history of the prices, of your prices over time before that day, and how you compared with your competitors over time. Because that is that has the biggest influence of the actual pickups, the on-rent you had on that day. It's your strategy, price strategy, and compared to the market. So actually, we think that it's very interesting to show you in the apps what was this pricing pace and what was the market during that time. And if we are able to model this, we can input this also into the forecast and find the correlation between the pricing strategy and how was the strategy compared to the market in the past. And so we'll be able, if we know your prices in the future and prices of the market, we will be able to input this into the forecast as well. All in all, forecast accuracy depends on the dataset size. How much data we have in the past, do we have the fleet, do we have rates, do we have fleet plan in the future, do we have rate shop in the future, do we have airlines data. All in all, that means the more data we have, the more accurate we will be. And last thing, something that we can do with with the forecast is make conditional forecast and make scenarios. So I've taken into account something that we can, I'm showing you something that we can already do. Like I said, I tried to input the fleet history in the forecast and the fleet plan for the future. So here on the left, I have made a forecast with an actual fleet plan that you can see here. And I have forecasted values here for the next 30 days. This is last year's on rent. And here I have made a virtual fleet plan. I have replaced the upcoming fleet plan with a straight line, but which is higher than the fleet plan on the left. And here the forecast has picked this up and made a prediction according to this new fleet plan. The difference is not huge on the screen, but you can see that it has adapted and forecasted higher on rent value for the upcoming 30 days. So we can so this is research on my computer to know how we will implement this in the apps, and we'll be able to show you all these scenarios we don't know yet. But we will be able, with different fleet plans or different pricing strategies, once we are able to analyze pricing strategy, to show you different scenarios of forecast. And this is actually the last slide. How it looks inside the apps at the moment. So it looks a lot like the bookings. You have the forecast, you choose a period, and you have your bookings. You have last year's data, last year's booking, last year's fleet that you can toggle, and you have 4 lines that show the forecasted values from 4 weeks, 3 weeks, 2 weeks, and 1 week ago, with the associated accuracy. And here you have a statistical table showing for all the period what was the mean 7 days accuracy, 14 days, 21, 28 days, standard deviation, median, percentile, statistical figures. I will not enter into account here, but everything you need to know to be able to analyze if the forecast from the past was accurate enough so you can have faith in it for the future. Thank you for your attention.